Hello, everyone. Welcome to the second workshop of the Core Global Gaming Hackathon. I am Mariam, contributor at Core, and your host for the day. And in our guest panel today, we have Rumeel and Akshaya from Core. Akshaya and Rumeel, please and what we are actually in this workshop today.
Hi everyone, I'm Rumeel. I'm contributor at Core leading the dev trail with my team. And today is the second workshop that we're going to do with technical. It will be a technical workshops where we are going to do the how to start your journey on Core, how you can create gamified applications on Core. Thank you.
Yeah, hi everyone. I'm Akshaya here. I'm leading the developer relations for India. And we hope you are excited as we are for the ongoing global gaming hackathon. And we wanted you to help you in building everything, get cleared with your doubts, and win amazing prizes from this hackathon. Excited to get you started with core blockchain integration.
So, as Akshaya has mentioned, Core Global Gaming Hackathon is all about empowering gaming devs, not just with a very massive price for the hackathon, but also with a lot of post hack opportunities. So, in our first workshop for the gaming hackathon, we explored the fundamentals of how to have good game design, which is a very essential part of building an engaging game that the users will love and will want to play and enjoy. So, in today's workshop, we take things a little step further. We will walk you through on building a simple game from scratch, and more importantly, we will tell you how to seamlessly integrate it with the best BTC-Fi ecosystem chain, Core Blockchain. So, without a further ado, Rumeel and Akshaya, the floor is all yours.
Thank you, Mariam. So can you share the screen? Akshay, your screen is not showing.
I think Akshay is having some technical difficulties. Meanwhile, Rumeel, can you walk us through about the Core Global Gaming Hackathon? We
Yeah.
already know that it has kicked off. The application period is going on, and it's been almost 2 weeks now. So, what opportunities, what benefits do the devs have from this hackathon?
So it's a core global gaming hackathon that we have launched it. Okay. So there is a multiple opportunities for the devs. One is that they can build on core build on Bitcoin. They have a chance to build on BTC-Fi number one chain. Second thing is about to the price distributions that there is 380,000 dollar worth of prices are there. It's a combined prices, so there are multiple tracks as well based on the positions and the tracks. The rewards are going to be distributed. Hyper tracks are hyper casual games, social games, puzzles games. So you can build any of it, and they're based on these tracks. There are the rewards. The first reward that we are providing is about the $15,000 five, so 5,000 per track. Beside that, there is a core starter program, core builder incentive, 6 month guest rebate program. So it's not about that you will just get the reward, but there is a post uh, post hackathon support is there. For example, about the core builder incentive, this is the builder incentive program that the core foundation is running, and those are adding the value to the chain. Either it is based on the TVL, based on DAU, they will monthly get rewarded. So, some prices based on some rewards based on core token. Our gas rebate that we are doing is about to the 6 month gas rebate. So whatever the gas that you are burning on core, you will get the full rebate from. You can get rebated by applying for the gas rebate program part. Core starter program is the program where you will get the subscriptions, some of the tools, services from our partner projects, from our infra provider about the security audit. So all of these things come into the core startup program, and bunch of other support programs are also there. our ecosystem team, our marketing team, once you're going is going to be launched on a mainnet, all of you will get to the full support, full throttle support from our marketing team, ecosystem team, dev team, engineering team, is anything that you have to require. So I mentioned about to the tracks part one. So there are three tracks: hyper casual games, social PvP games, and the puzzles games. So in hyper casual games, you can create fun, addictive games for a broad audience, that you can create the any addictive game that which is the hyper casual. Second one is about to the social PvP. So build multiplayer games, like you can create about to the Ludo Star, Need for Speed if you want to build puzzles game like the mind games, snack games, card games. You can create in this tech as well. So Akshay is there.
Yes, I'm here.
Right.
Yeah.
So today, that's what actually we are going to build. We had this is the technical workshops. Akshaya, my colleague, she is going through the workshops where she will explain you how to integrate the MetaMask wallet to Core, how you can start your journey from as a newbie. Just consider that you are a newbie, you want to start on Core, you want to build on Core, you want to launch on Core from testnet to mainnet. How you will do? What are the tools you have needed? How quickly you will build it, and we will show you that how easily that you can build on Core. So Akshay, stage is here.
Yeah. Thank you so much, Rumeel. So let's get started. So what are we going to build in next 30 to 40 minutes is we are just going to build a very simple DApp. As Rumeel mentioned, even if you are new to Web3, you can learn from this. So as the name suggests, it's a guess the number game. So you just need to enter a number between 1 and 100. If that number matches with the secret number or the pseudo random number generated in the Solidity smart contract, then you win, which means you will also get a rewarded with tokens. And if not, we will give you a clue whether if it is lesser number, we'll mention that the number you have entered is too low, so you will be trying a higher amount than that. Or if it is too high, we'll mention that the amount is higher, you need to enter something called lower number. And once you crack the secret code and won the game, so we will be resetting the game and the new game will be started. So to do this, there are a couple of things that are prerequisites. We need to set up that. Hope everybody has Node installed. So the recommended version is version 18.8 or later. You can also use 20, and npm or yarn for the package dependencies to manage packages. And we also need a MetaMask browser extension. Please go to metamask.io and install the browser extensions for your Chrome. So once we set up all of these, we need to set up our MetaMask. We need to connect our MetaMask to the core blockchain testnet. So let's see how we can do this. We just need to go to chainlist.org. So I already have that. So once you go to chainlist.org, make sure that you click on this include testnets and search for core blockchain testnet 2. So there are two testnets, which is the latest testnet is called testnet 2, which is integrated with our Bitcoin testnet 4 to enable testing the BTC related features very easily and convenient way. So once you search for core blockchain testnet 2, you'll get the chain ID, which is 1114. So click on connect wallet and add it to your MetaMask. So I'm just clicking on that. So if you see, my account is already connected. Since I've already added, so it's already there in core blockchain testnet. To make sure you click on add MetaMask. Okay, so now we have MetaMask setup and it is also connected to core blockchain testnet 2, but we need testnet tokens for that. So in my account, if you see, it's in core testnet 2, but we only have 0 T core 2 tokens. So let's get that. So for that, let's go to docs.core.org and navigate to build session, where we will have code for developers connecting to core. We have all the network configurations over here. In case if the chain list is not working or you don't want to connect through that, if you want to manually add the network to your MetaMask, you can also follow this steps. You can the network name, RPC URL, chain ID, and everything. So we need to get the faucet. We need to get some tokens in order to deploy and interact with the core blockchain. So go, navigate to this faucet website link, scan.test2.btc.network. So let's enter our wallet address. And
Actually, what is the difference between testnet and testnet 2?
yeah, so as I mentioned, testnet is connected to BTC's mainnet, so that it is little hard to test BTC related features on core. And if you want to test any BTC related features on core, you can use the latest testnet, which is connected to Bitcoin's testnet 4, so that you can use the testnet BTC for testing all your BTC related features.
So is there any plan for the sunsetting the old test, or the both will run parallel?
Yes, so the older testnet will be sunsetted, but we are not sure on the timeline. It would be sunsetted soon. So it is highly recommended to use Core Testnet 2 for all your developments so that you remain stable with your development.
Perfect.
Yeah. So since we just entered our wallet address, we got the transaction and we got the tokens. Let's check the balance over here. Okay, now we got one T core. Right, and this faucet enables only one core token per 24 hours. In case if you need more testnet tokens, please reach out to us in Telegram or Discord. We are happy to supply the required tokens for your dApp development. All right, now we have the MetaMask setup connected to core testnet 2, and we also have faucets tokens to with. Now let's get started with the actual coding. So we are going to see the coding in two different steps. So one is I'm going to explain the hard hat, the smart contract part in every detail step by step. So we will start from scratch. And I will also show you the front end, how to integrate it. And I'll explain the code of how to integrate our smart contract, copy pasting the ABI and integrating it, connecting the wallet, and playing the game as well. Probably we'll have a demo of how the game looks in the front end. So before that, let's get started with our ordered project. So I'm just going to create a new directory for now. So let's name it workshop 2 for now. I'm just going to that. So now we need to initialize our package, which means npm init-y. So this has initialized our projects in the workshop 2. We can see the package.json file. So now once this is ready, we need to install hard hat. So we can also show you the hard hats. So if you go to hardhat.org, you'll have a detailed steps of how to set up the project. We already done the step. We just need to copy paste this npm install save hard hat.
Actually, what is the difference between hardware and why you are using the hardware instead of any other tool?
So hard hat is the most famous framework for Ethereum development, Ethereum-based developments. We also have Foundry. Truffle and everything was sunsetted. It was used previously. Hard hat and Foundry are the most familiar framework to write and test smart contracts. Hard hat is much easier than the Foundry. So we are using hard hat for the seamless development and integration.
Good. Okay. Okay.
Okay, so let this install, and then we just need to initialize our npx hard hat unit, so which will initialize a sample project with the structures and it will also ask us a couple of questions. So don't worry, we'll just navigate through that. So you can see the node module since it's installing every dependencies, and we have node modules set up and everything. Okay, so the package installation is done, hard hat is done. Let's initialize the hard hat project. Npx hard hat init is this terminal command name. So this gives us with a couple of questions. Create a JavaScript project or TypeScript or you can create a TypeScript with Vim and everything. So we wanted to create a JavaScript project, clicking on that and doing it
And
in
Akshay, if
the,
I ask, can we create to any language JavaScript, TypeScript, or any language to build on core, or is core is depending on only the one language JavaScript?
no, Core is compatible with JavaScript, TypeScript and everything. So whatever the Solidity EVM base supports, everything is supported by Core. We can build in any language.
So it means the any developer who have TypeScript experience, JavaScript, Python, they can easily build on core. The EVM
Yes,
supported part core.
yes, we
Awesome.
can. Yeah. Okay, so what we have done, we have used JavaScript for now, and the project root I have mentioned the same as the parent folder, and we are adding a git ignore. So whenever you're storing the private keys and stuff, we wanted to make sure that it is safe. You're not uploading to Git, and install the sample project, which is Normie Foundation Hard Hat Toolbox. It's a main dependency, so we need to provide yes so that it will also install that. Okay, once it is installing, I'll go to, for this we need to create a ERC20 token. So I'm going to open the plain wizard. So this ERC20 token is going to be used for rewarding. So whoever guesses the correct number, they'll get this ERC20 token basically. So this is one of the easiest way to get started with ERC20. Just go to,
Akshaya, you're breaking. Your voice is breaking.
uh, mm, okay,
Yeah, and I think now it's fine. Now I think
is it
it's
fine?
fine.
Okay. So I was mentioning we need to create an ERC20 token uh, because this is what we are going to reward the winners with. So you can go to open the plain wizard, click on ERC20. So we will have a sample code over here. We can just reuse it, and you can also edit the code using these whatever functionalities that you require. We are going to mint some of the tokens. I'm just studying mint. If you want to burn some of the tokens, you can enable these block number, and if you want to upgrade your
You are
contract.
still you are breaking. You are breaking.
Uh, I think I need to slow down. Uh,
I think Akshay is having some technical difficulties. Meanwhile, while she tries to reconnect, Rumeel, can you please walk us through the what is the benefits for Core for developers to build on Core, like EVM compatibility, and what else do benefits do they have?
Yes, there are multiple benefits for building on core. Uh, this way, I can
Yep.
give you the answer. Then I will hand over to Akshay. That you can build any application on core by using any language that I mentioned about. Either you are a JavaScript developer, TypeScript developer, anything that is compatible. If you know how to build on EVM, you can easily build on core as well because of the EVM compatibility. And the second benefit is that you are building your applications from the Bitcoin Bitcoin bag applications. We're building the Bitcoin bag applications. How the novel Satoshi Press consensus protocol that Core have, which is delegated proof of work, delegated proof of stake, and delegated proof of non-custodial BTC staking. So your application is not about to be say running back to the just for the proof of stake validator, but there is a hash providers that they are delegating their hash, and your application is going to be safe, secure by Bitcoin. Bitcoin, you can say miners. Bitcoin miners are securing your applications with the chain validators as well. So Akshay, yeah, you can take it.
yeah, thank you, Ramil. So hope my voice is audible and the screen is also visible.
Perfect. Yes.
Yeah. So we just modified the token name and the symbol. So you can just make guest token as this. and we have enabled Mintable. So you can copy this, go back to our project folder. So under the contracts folder, we already have lock.solidity file. So let's just create a new file over here, which is called guesttoken.syl. And we are just pasting this out. Okay. So meanwhile, in order to run any other third-party smart contracts, we are using ERC20, Ownable, and everything from OpenZeppelin. We also need to install this package. So we just need to do npm install OpenZeppelin/contracts. So let this get installed. Meanwhile, let's create a new one, a new contract, which is a game contract. So I'm naming it as guessgame.sol. Okay. So let's get started with this. We'll just initialize the contracts. First, we need to add our SPDX license identifier. This is completely optional, but in case if you don't want any warnings during the compilation process, you can include this. And we need to mention Pragma Solidity and the compiler version that you want. Since this is greater than 8.19, it will compile with whatever the version which is greater than 8.19. So the latest version that Hardhat uses is 8.28. So we are good to go with that. And importing Ownable and IERC20 interface from OpenZeppelin, and initializing the contract with contract guess the number is Ownable. And these are the state variables that we want to add. So one is secret number, which we are going to generate the number and store it over here. And last winner, whoever wins the game, we will just update the winner of that particular wallet address. And mapping. So there are multiple people, they can participate in the game. So we are mapping each member's address to the number of atoms that they did in a single game. So that is called atoms. And we have reward token, which is again a ERC20 token. And we have a reward amount. So we are mentioning all this in the state variables. And we also need to log some of the events. So I'll just add the events list over here. So there are 3 events in this, which is one is game started. Once the game is started, even after resetting, when the game started, we will log the block number. Guess made. So whenever a player guesses making the guess, we'll index the player's address with the number that they entered for guess and the message. And the game won. So here, whoever is the winner, we will log their address, the number of attempts that they used to win the game, and the reward amount that we are going to send them. And let's get started with the actual logics. So first we need to have a constructor. So in the constructor, if you see, we are giving a 2 parameters during the constructor, which is reward token and the reward amount. So reward token is nothing but the address of the guest token here. We will be deploying this guest token. We need to provide that particular address. And the reward amount is nothing but the number of tokens that you want to give reward to the winners. So initializing the ERC20 over here, and the reward amount, the state variables will be updating the reward amount with this and resetting the game. So for reset game, we have this function. This is the reset game function, which is a public function. So we are generating a secret number. Remember, we have the state variable over here. So it's a secret number. We are going to generate this pseudo random number. So first I'll explain you step by step over here. First, we are getting the block number -1. Block number is the current block number. -1 will give you the previous block number, right? And we are getting the block hash of the previous block number. So the one parameter is called block hash, the block hash of the previous block number, and the block dot timestamp, which is the current time and Unix timestamp. So once we have these two, we are encoding it. We are packing this variables and using a Kerak 256, which will encode and give it to you in 256 hash bytes. And once we have the hash bytes, we are converting that bytes to you in 256 in order to play with the number. So this will just give us a hash. But once we do it with UN256, we are converting that hash to a number. So we have a number over here, which will be a 256 length, 256 bytes of length. Then we will modulo by 100, because we need to guess the number just between 1 and 100, right? It should be less than 100. So we are doing a modulo, but once you do the modulo, you'll be getting the output as 0 to 99. So we want 1 to 100, just that we just incrementing it with plus 1. So now we have a secret number. So this can also be hacked by anyone, but this is just a pseudo random number that we are going to create. And if in case if you want to make it more secure, you can also use VRF method functions through third-party APIs. So we can do that. And attempts, whenever we are resetting the attempt, we are making the attempt to go back to 0. It will start from 0, and emitting one of the logging the events, which is game started. So once the game is resetted, then we are making a guess. So we'll write that function to make a guess. So here we will be entering the players used to enter the number, which would be 1 to 100. So if that is not matches, like if they entered around 120, it is not matching our constraint. So we will be giving out the error as it must meet between 1 and 100. And atoms of message.sender, we will be incrementing each of the players' atoms whenever they are making a guess. Okay, now comes the interesting part. Whenever they are guessing, we will check whether it is matches with the secret number which is generated during this time. So if it matches, they are the winner, right? So we will update the winner to the message.sender. And if we have a balance of reward token in this particular contract, we will transfer the rewarded amount to them, and emitting game one with the necessary details, and again resetting the game. So if the guess is less than the secret number, as I mentioned, suppose consider the secret number is 55. They made a guess like 25. Then we'll say that this is too low, you should try a higher amount. Or if they guessed like a 75, that is like 55 is lesser, right? So we'll mention this amount is too high, you need to try a lower amount. So this is what make guess works. And we are having additional 3 functions over here. So I'll just explain this quickly, which is set reward. In case during the constructor phase over here, we have set it like 10 tokens as a reward. But in case if you want to update that as 2 tokens, you can do that by set reward function. You can update whatever the amount you want. But it can only be done by only owner, which means whoever has deployed this particular contract, only they can access this function. And deposit rewards. So in case the rewards are not enough in the contract, like there are only 2 3 rewarded token, we want to make this game more interesting, want to reward them higher, you can also deposit some of the tokens from you, which means transfer from message.sender to address of this represents the current contract address. So if it is not transferred, we will say it's transfer failed because of balance issue or anything. We'll just emit with the transfer failed event. And withdraw tokens, this is one of the most important one. Whenever you're creating a contract, make sure you write some function to withdraw the stuck tokens in the contract. For now, we are transferring reward tokens. So whatever the amount that we enter, it should match with the contract's balance. So we will transfer that particular amount from the contract to the message.sender. And additionally, if you want to get the number of attempts by each player, we can also write particular view function for that. And if you want to review the secret number, you can also do that. So we have done with the contracts. Let's try to compile it. npx hard compile. Okay, now we already have compiled it. So let's take a look at our hard config file. So this is what the current initialization setup will look like. So this will just give us a support for hard which is a local development environment. If you want to connect our hard hat or the environment to the core blockchain testnet, we need to configure this config file. So I'm
I have
just
a
adding a
question.
network. Yes.
Uh, what does
Yes.
mean by the compile, learning the code, deploying the code? How actually this is the Solidity smart contract? How I will be communicate with my front end? So how you will, what
Okay.
network it will be, where I'm going to check network configurations? What will be the process?
Okay, so there are two steps whenever you are writing a smart contract. First, you need to write a contract and compile, which means it will convert the human readable format to the bytecode and everything. So that is what you need to compile a contract. And whenever you are compiling a contract, you will get the artifacts over here. So in the artifacts, if you see, there is a subfolder called contracts. For each of the Solidity file, we will have a distinct folder, and you can get the ABI from here.
So the bytecode is
So
going to
guess
be
the number
changed.
dot
So the
JSON.
bytecode is going to be changed to application binary interface ABI format, right? And we will
Yes,
use
it will be,
and we
yeah,
will use this ABI for communicating with our front end.
yes. So once it's deployed, you need to copy this ABI file, and that will be used for the front end to integrate
Awesome.
with the front end and interact with it.
Clear.
And in the hard hat config, we just add a hard hat localhost for now. So we can configure the networks. So you can also have hard hat over here in case if you're testing it out. And now I also need a custom token, which is code testnet. So we need to have a URL. So you can get the URL from our website. So this would be the URL. And the chain ID, which is, oh, sorry, 1114, as we mentioned before, and account. So account don't paste your private key directly over here. So you can create a new file called secret.json, and this is a JSON file. So I'm just writing a private key. So you can enter your private key over here, use this, and let's just import that. So we have imported the private key from the secret.json file, and you can use this private key over here so that you can use this particular account and deploy the contracts. So now we have contracts ready, which is guest token is ready, and the actual game of the contract is also ready. And we have our hard hat set up for core testnet 2 with the URL, chain ID, and accounts. And we also have local hard hat in order to test and do that. So now we are going to create a deploy script. So you can just directly create a new folder called scripts. So in this, I'm going to add a file called deploy.js. So this is the actual file. So let's speed up the process. So this is the deploy.js file. First, get the hard hat initialized in this, and I'm creating a async function, which is main. Get the account with ethers.getSigners. It will give you a list of accounts. So basically, it might, if in case if you're running it locally, it will give you a 10 accounts. And if you are configuring the private key, it will give you the correct first account if you are writing only one private key. And then we are initializing the contract, which is guest token contract. So ERC20 contract that we did. So contract factory had the contract name, which is guest token that we already mentioned. And we are deploying that with account 0. So if you see to guest token, in the constructor, we have added the initialize owner function. So we are passing who will be the owner of this particular token. So that's why we are passing account of 0 as the parameter, so that it will take this particular address as a owner. And then we are naming the guest contract. So I think the guest name, this is a contract name, guess the number. So we have guest game contract, get the contract factory as guess the number, and then we are going to deploy this particular contract. So guest contract dot deploy. There are two constructor variables here, which is reward token and the reward amount. So right, so we are passing the guest token contract dot target, which means this is the first contract, ERC20 token contract. We are passing that particular address over here. And if you are using the latest hard hat environment, it would be target. If you are using the previous versions of ethers, it will come as address over here. So we are using the latest one. So make sure that you are giving target over here, so that it will take the contract address of the deployed contract address. And we are rewarding the setting the reward amount to 2 ether, so which means 2 token per reward, right? And then so we already have 2 particular contracts deployed, and for the token contract we need to mint some of the ethers, right, some of the tokens, in order to transfer it to the gaming contract and integrate with it. So for that, I'm just directly minting it. So this would be this I'll be the executor of this particular function, so I can transfer it to anyone. So in the mint function, I'm adding the game contract as a target. So that address, I'll be encoding it over here as a param, and then I'm providing 1,000 tokens for the gaming contract, so that whoever plays and wins, they can check it. And you can also check the balance of the contract. So just check game contract dot target, the token contract balance of the game contract address, and you are logging the balance. We'll log the balance over here. And we will also log other 2 tokens, which is the ERC20 token and the game contract address. We will log both of this, so that that will be used to integrate in our front end. So we have our deploy script ready. Let's try to deploy it. In order to deploy, you need to use npm hardhat run scripts / deploy.js. So, okay, wait, just give me a second. It didn't find. Okay, I have added a dot over here. That's why I couldn't find it. Sorry, I'm just removing the dot. Okay, go back to this. Now we have a secret.json file, and I'm just deploying it in our local environment. So in order to do that, you can configure this with -- network, and I'm just making it as deploy to hard hat. Okay, since we didn't provide the proper key over here, it is considering that one. So let me just enter the proper key, proper 32-byte key, so that it will give you it. Let's try it now. Give me a second. I'm just configuring that. Let's ensure everything is matches. Let's try it once. Let's see. Okay, I think I need to enter my actual private key. So I'll do that offline and do that. Can we go to the backstage so that I can enter the private key over here, please? Am I in the backstage now?
Yes, yes, you are.
Okay. So you can go to MetaMask, click on account details, and click on show private key. It will give you the private keys. So you can just copy that and paste it over the JSON file. Make sure you include that in git ignore. Can we come online?
You are actually.
Yeah, okay. So I have entered my private key in the secret.json file, and then we just ran this deploy script, which is npx rdat run script slash deploy.js, and I'm just deploying it to our local rdat network. So, and since you see we have logged three different things, which is log of balance, we'll log the balance, and also the ERC20 token, the reward token, this is the actual gaming contract. And if you want to deploy this to code testnet, you just need to make sure that same one, network, and make sure that you're including this particular naming, whatever you have mentioned over here. So in my case, it is core testnet. So always make sure that you're first deploying it in the mainnet and then the doing this. Okay, and
Actually, your RPC test 2 or which one? Can you check? Yeah.
yeah, sorry. Thank you for that. Okay, so we are updating the proper one, RPC testnet2.btc.network. So we were configuring the private key, so that time we made it changed. So make sure it is testnet2.btc.network account with the private key, and the chain ID is 1114. So let it deploy to our core testnet. Meanwhile, I want the one. Okay, it's already deployed. We have this token contract initialized. So I think the balance is not properly fetched. We'll just deploy it again. We'll see the proper balance. So you can follow the front end with CodeHouse GitHub. Let's just go to codehouse.org in the GitHub. You can see DApp tutorial over here. So this has list of sample dApps. Everything is a full stack app you can refer to. So there are so many apps you can clone the repo and try each of them. So for this tutorial, we are using this particular one, which is called Guess Game. So directly clone this repo, git clone with this ID, and you can navigate to this folder called Guess Game. So after cloning, navigate to guest game and do the npm install, which will have all the hard hat configuration installed. And then you need to go to cd./frontend, which will have all the frontend. Frontend would be in Next.js, and you also need to do an npm install over there. So let's get back. So there is some issue with fetching the token balance, so that's fine for now. So we have deployed it to our core testnet as well. But once you deploy the same script to the hard hat network, and if it is working fine, then we don't have to worry about it. So everything is ready. We have contracts compiled, deployed. We also have the contract addresses of both the contracts, and we also have,
What,
yes.
Akshay, what is the meaning of the contract address where you will use
Yeah,
this
so I'll
and why you have two contract addresses?
So we will use this contract address and ABI in order to integrate with the front end and interact with our DApp, interact with this main contract basically. So we have two contracts. One is the ERC20 contract, which is the rewarding contract. Whenever user guesses the correct number, we will give them two reward tokens, which is GT token in our case. So this is the actual contract address of the gaming contract. So this we will be using in the front end to interact with it.
You have mentioned about to the ABI. Can you please explain me what is ABI and how actually it will work?
So ABI is the application binary interface. So whenever you're compiling your contract, it will convert to the bytecode, right? So during that phase, we will also get an ABI. So as mentioned, artifacts, contracts folder, we will have a different distinct folder for each of the contract that we have compiled to. So you will get the ABI over here. So in this ABI, it will have everything format, contract name, source, the bytecodes, everything over here. So we just need the ABI and the contract address so that we can integrate it with the front end and interact with our DApp. So I'll show you where exactly we are using this, but remember this is the ABI that you need to use. So
So
just copy paste this code.
it means that the ABI is the uh, contract can be converted into the all the functionalities of the smart contracts are converted into the JSON format, so
Yes,
you can do it with your front end. Okay, cool.
yes. So it will have all the inputs, the function name, everything. So one of the function is non-payable, which is constructor. Uh,
Mm.
and we also have game. So guess made. This is one function name. So whatever the inputs that we give, whatever the events, everything will be mentioned over here. Okay. So let's hope you have navigated to guess game. First install, do the npm install in the root folder, and then go to front end. And you should also have this front end ready. Wait. Okay, so go to app. We have components. This is for all the buttons, card inputs, and everything. The main page is called page.txx. So this is a file, main file. And if you see, here is where we are importing the ABIs and configurations. So Solidity ABI, where it is in constant/Solidity ABI. So go to constants folder. You will see the config.json and Solidity ABI. So which is nothing but we just copy pasted the guest tokens ABI over there and pasted it over here. Just the ABI. You don't need to include the bytecode or anything with the square bracket. And in config.json, so for each of the chain ID, you can mention this particular address. So this is the guest game address. This is the token address. So as we deploy to code testnet, you can also mention whatever the address. So if you're deploying it to multiple blockchain, you can have a single file and refer to whatever the chain that you want to connect to. You can get the address from here. So we have initialized the front end. Solidity and config file is already pasted. We have imported them. So let's see how it works over here. So first, let me go to okay. So I'm just going to cd dot slash this game slash front end. And once you have installed, we just need to do npm run dev. Okay, so as mentioned, we need Node version of 18.18 or greater. So I have an NVM so that I can navigate between different Node versions. It is highly recommended to use it, or you can also download the latest Node version and use it. NVM use, I'm just mentioning it as 20 for the safer side. Okay, so now I've switched my node to 20.11.1. And now let's run our front end, npm run dev. Okay, it started. Let's go back to our Chrome page. It is in localhost 3000. All right, so we have a front end ready, which is guest number. First, we need to connect our wallet. So in order to do that, I'll show the code over here. So this is the functionality function for connecting the wallet. So first we are checking if it is connected. If only if it is undefined, it says that it's not connected. So we are trying to connect with ethereum.request ETH requested accounts. That is the method that it uses to connect our MetaMask wallet to the browser, to our dApp basically. Once it is connected, we need to set the account 0, the latest account that we are connecting. Will be setting that account. Set is connected equal to true, and we are just setting the message. These are additional state uh, local variables that we are updating to the state. Just that if the wallet connection is not proper, if it is not able to connect, we will say it failed to connect the wallet. Or if even if it is not an error message, or even if nothing is wrong with our dApp, but the MetaMask installation, it's not able to open the pop-up or something, we will set the message to please install MetaMask. So let's try to connect now. So actually I'm getting my approval in the other screen, so you will not be able to see. So I have connected. Now if you see, it's connected to this site. Account 2 is connected. This is the one. So we have tokens. Since we have deployed couple of contracts, it got reduced. So it's connected over here. We have tokens to play with. Let's guess some game, guess some number. So I'm just writing 54. Let's see if this is works. Clicking on guess. It opens a MetaMask pop-up, asks us to confirm the transfership, confirm the transaction. I'm just confirming it. Okay, so it's too low, which means we have entered 54, but the secret number is greater than 54. So we need to try a new different amount. But I just had a hack. So in order to give you a one, so I'm just going to the console and see the target number, which is 55 as given us in our example. So this is the correct secret number. Let's see what it does. So guess token, I'm just guessing it, confirming the transaction. It also shows the attempt. So we already had one attempt, but in second attempt, so we already guessed it right. So we have this particular confirmation. And also we need to check whether we got a reward for this. So
Okay,
before that,
can you also show us that where you have connected and where is the ABI is using?
yes. So first we have connected our Connect wallet, which is here, with which I have showed the functionality. And next we are handling the guess, which is the provider and factory. If you go to handle guess, this is the function that we have, provider, the factory. So
And where
first we
is
are
the
getting this
ABI?
value.
Where is the
Sorry.
ABI? ABI
So
that you are using?
it is already configured over the factory. So here.
Perfect.
So
And
we are
what is
loading the blockchain network over here.
contract factory actually?
So contract factory is where we are configuring the contract. So remember, we already have the address and everything, right? So we need to configure this, initialize the contract, new ethers.contract with the contract address that we got through deploying the contract, and Solidity ABI. ABI is nothing but the JSON file
Yeah.
which we add. So we need to provide that, and the provider is the Ethereum provider. So we are using a browser provider. So you can just configure that and use the provider over here in order to deploy that. And if you have any other third-party providers, you can also configure that using the URL.
Perfect. Can
So
you
you
show
can
us the
also,
reward?
sorry, can you come again?
And can you show us the reward?
Reward, yeah. So going to the config.json file. So we know this is the ERC20 contract. So copy this address and go back to your MetaMask. So we need to import this token in order to see if it works. So click on this three dots over here, plus import token. I'm entering the contract address. So this is the token symbol, decimal, everything. It will come automatically when you paste the contract address. So next. So if you see, we have two GTK tokens. So import, you can see We have two tokens. This is the reward tokens that we got. So if you didn't make a proper guess, you will not get any. But if you make a proper guess, so can we try one more guess? Okay, so now I'm just entering 5 for now. No, so that is 95 is a correct secret number. So let's enter 95 and see, we only have 2 GTK tokens. Now we are entering 95. This is the correct secret number. And once we guess this right, we should get 4 GTK tokens. So I'm just confirming the transaction. Congrats, guess. Let's see the reward tokens over here. So now you see, we have 4 GTK tokens. So this is a simple game where you are just entering some numbers. If it matches with our correct pseudo random number, the user gets reward. If not, we are tracking their atoms, and additionally we are giving a clue whether it's too low or too high so that they can make a guess accordingly. So this page has all the things like handle guess whenever we are connecting it. So whatever the contract functionality validations that you have mentioned, we are entering it over here: too low, try high number, too high, and everything. And reset game. So in case if you are working, you cannot crack the pseudo number. So you can also reset the game, which will set a new secret number, and you can play accordingly. So that's it. Hopefully, it helps you on how to integrate, how to first configure code testnet 2 in your hard hat, and how to deploy contract, and how to integrate your contract in the front end. Hopefully, this helps for everyone. If there is any questions, happy to take it.
Awesome. Awesome. Yeah. So Akshay, thank you for the detailed workshops and the detailed orientation of the presentation as well. So if you can go back, Mariam, I think there is, yeah. So for our upcoming timeline for the workshops, I think it will be on Feb 25. So this is the second workshop that were called blockchain integration, that you have seen that how actually you can integrate, not it's more than integration, that how you can create the application by just integration of the MetaMask, right? Just contract, then your smart contract converted your API JSON files, all of this, and communicate with your front end. So all these things are available on our GitHub. You have to go onto the Code.io GitHub. Dev tutorials are there. Copy any of it, clone it, run it, and if you have any questions, you can ask us onto our forum. So the next workshop will be the game art essentials, and then the science of the game mechanics from our gaming ecosystems. They will explain you how essentials, how important the art is in the game part. So there will be a proper guideline, proper sessions will be on it from our industry experts. They will guide you how you can use as a good artist, how you can design your game. Next slide, please. So for the reach out, Telegram, Discord, and the dev forum as well. Q&A. So Mariam, any question? What level of projects are you expecting for the hackathon? We are open for it. As I mentioned that there are 3 tracks. You can use any of the track, or if you think that you can build out of these tracks, we are open for it. So we are, you can say, projects agnostic. You can build any application on core which suitable for you and which can easily that you can build it. Is NFT based? Okay. Yes, you can create NFT based game applications. We are open for it. Yes. Any other question? Yes, Akshay, you can wrap up.
Yeah. Okay. So All right, hope this was helpful for everyone. So, in case if you have any further questions, you can always reach out to us in Dev Forum, Discord, or Telegram. We are happy to assist and help you start building on Go. Thank you so much for listening. Thank you.
Thank you, everyone. Bye bye. Take care.